So we're live now. Hello and welcome to this conversation with Intracom Telecom. My name is Frank Rayal. This conversation is part of a Selfalignment report on small cell backhaul that gives an update on small cell backhaul solutions and on the evolution of the mobile operators' requirement for small cell backhaul. Today, we're talking to Babis Papanastasiou, who is the product line manager at Intracom Telecom. Babis leads the product management for the street node and the point-to-multipoint Babis platform. Intracom Telecom is a major vendor of point-to-point and point-to-multipoint wireless backhaul solutions. And thank you, Babis, for being here with us today. To start, I would like to ask you to give us a brief introduction about yourself and Intracom and your product line. Please go ahead.
First of all, it's a pleasure for us to participate in this report, discussing a very interesting point such as small cell backhauling. For us in Intracom and having more than 15 years of experience in wireless technology and providing a wide solution portfolio ranging for point-to-point and point-to-multipoint technology, having the ability of combining these technologies together and providing the optimum solution to our customers. We have also recently addressed the needs of small cell backhauling with a new and I believe very interesting solution, which we name Street Node. This is, I believe, the topic of this interview today.
Yes, absolutely. The Street Node product seems to be very interesting. I've already reviewed some of the material on that. If you can position that product for us, please, to describe it and just describe how it works and the frequency band it operates in. I understand it's a wireless solution, so please go ahead on that.
Okay, so we are positioning our solution in the microwave technology. It's a microwave system operating at area licensed frequencies. This is the 26, 28, 32, and 42 frequency bands, where the operator has the ability of getting a license for a full area and then have the ability to deploy the solution without having to go back to an authority and getting license per hop. So first of all, this makes the solution very attractive to start with. And we exploit the benefits of the microwave technology. Microwave technology is a mature technology. It has a lot of benefits. It's a carrier-grade technology. And we have taken all these benefits of the technology, all these advantages, and now we have put them in a very, first of all, attractive size, because Street Node is a very small unit. It's only 4 liters of volume. It blends in the urban environment. It's almost invisible, and it can be installed in lampposts or walls in an urban environment, and provides very efficient solutions for the small cell backhauling, being first of all a carrier-grade solution. It has line of sight, so it is very deterministic, the way that you can dimension your network, you can design your network. You feel confident that once you have designed your network, you will get the performance that you expect from your network. And it is a carrier-grade solution, which we believe is mandatory for a backhaul solution.
Mm-hmm. So you mentioned it's a carrier-grade. You mentioned it's a carrier-grade solution. Would you please expand a little bit more on that? What do you mean by carrier-grade solution, and what are some of the features that the product has that would make it carrier-grade?
First of all, as I said, it's a thing that when you design, it's a deterministic way of designing the network, so you feel confident about the performance of the network. It has high capacity. We are offering 540 megabits per sector or per link, and we can have aggregation hopes with just 2 channels of 56 megahertz that can give 2.2 gigabit capacity per aggregation hop. It has minimum latency, below 1 millisecond or even less than that. And it has the quality of service. It has all these mechanisms that are needed for a carrier-grade solution.
Mm-hmm. And you mentioned it's a point-to-multipoint solution. Would you comment on how many multipoints the solution will be able to support?
I would like to make a note here and correct this misconception somehow. It's not a point-to-multipoint solution. It's a very flexible solution that can accommodate any type of architecture. So it can be point-to-point, it can be point-to-multipoint, it can give relays. So we can extend the connectivity within the urban clutter and create relays that literally reach any location. So it is a line-of-sight solution with a carrier-grade characteristics of a line-of-sight technology, but also we have all these mechanisms that bypass the problem of line-of-sight, which is that we cannot reach any solution. With our solution, with our proposition, we can reach any solution implementing relays in the urban environment. Mm-hmm. If we were talking about strictly point-to-multipoint, which is your question, we can aggregate from a single hub, I believe, 30 terminals. But it's not only a multi-point solution, it's a very flexible solution that can adapt to the needs of a specific network deployment.
Yeah, I think the support for the relay is interesting because you have mentioned that you will be able to go deep into the urban clutter. And I think that's probably an interesting point if you can expand a little bit on that to basically help the audience also try to understand that a little better of the relay functionality and how you reach deep into the urban clutter.
Of course. First of all, we exploit the benefit of a multipoint, and the benefit of a multipoint to start with is that from a single hub, you can have many terminals, and this in principle gives you less equipment, and less equipment can then translate to less expenditure. But then you cannot really reach any point from a central aggregation point. You need to extend connectivity, having a very flexible solution. Another key point of our proposition is that we are having a single unit which can be defined by software. It's the same hardware, and that's this different software that can define the operation of the unit. So the unit inside the urban clutter can operate either as a terminal or as a relay point-to-point extension, or as a relay point-to-multipoint extension in the clutter. So by putting together 1 or 2 units in a lamppost, we can extend the connectivity and reach locations where do not have direct line of sight.
Mm-hmm. All right. I also saw that the product has a feature that supports self-alignment. Can you expand about that, please?
That's another key point of our proposition, because we need to bring intelligence into our solution. We are talking about a dense deployment of small cells, and if we're talking about a massive deployment, we need to have the intelligence in our solution that will simplify the installation, provisioning, and later maintenance of the network. So auto-provisioning is a key feature of our solution, in the sense that we expect that non-skillful personnel will have to carry out the installation tasks. So aligning a point-to-point link can be sometimes very complex and time-consuming. And imagine that imagine the locations where this is going to happen. It's going to happen in an urban environment with a lot of traffic, with cars, people going by. So you need something that will be realized very quickly. Auto alignment gives this option, because the system has the ability to find the optimum position, the optimum location, and align to the other end automatically. So you just power up the device, and the device will find the best position and align over there. Furthermore, as a next step, the system will do the auto provisioning. So all the configuration parameters, all the profiles are offline created and downloaded directly to the node. So by the time you power up the device, very simply in a few minutes, automatically the system, the node will go alive.
Mm-hmm. That's very interesting. Also, in terms of the, I mean, you've already mentioned a number of features there, but what do you think is the best, or how would you describe the competitive advantage of your product, of your solution and technology over others?
First of all, we are talking about a frequency band that is already there. It's a local location spectrum, which can be reused very easily and provide very efficient solution. It is a solution that can reach everywhere with carrier-grade connectivity. So introducing the relays, we can reach everywhere with carrier-grade performance. It's a very flexible solution. We have a single hardware, a single unit that can be software defined in various operation modes, either point-to-point or point-to-multipoint. So imagine how much logistics are simplified when you have to deal with a single hardware unit, which at the other end can operate in various modes and provide solutions to reach anywhere in the clutter. And also exploiting the benefits of the multipoint with less equipment and less expenditure is something that should be also considered very much.
Mm-hmm. Now, one issue that I'm just curious about is the area spectrum license. Is that widely available? Let's say, I believe it's in many countries. Do you have any idea in terms of the cost of spectrum, how much this kind of spectrum would go for, and how that factors into the operator's business case? Any comments on that?
It is available in this. The higher the spectrum band, it gets less utilized. And recently we see the higher bands open in many countries. And also recently we have seen a very attractive licensing scheme adopted by the authorities. So that makes that spectrum quite attractive. The other thing that I want to mention also is that our solution is deployed at the street level. So the microwave transmission at street level somehow is decoupled from whatever happens on the rooftop level. So we could have traditional microwave links rooftop to rooftop, and at the same time, without any interference, we can reuse the same spectrum inside the clutter and provide very efficient solutions. Also consider that many tier 1 operators today, they might have this spectrum and they may underutilize this spectrum. So effectively, they can deploy our solution without any additional cost at all.
Mm-hmm. That's interesting. So when you look at the, when you're speaking with operators, what do you hear as the major concerns or the major issues that they encounter in small cell deployments and small cell backhaul? And how have you addressed those in your product line too?
Well, the small cell is a very hot topic, and all the tier 1 operators are being preparing for this. So addressing the needs, providing a solution that it is carrier grade, and backhaul is always considered as a carrier grade technology. Having the capacity and the latency requirements to satisfy the upcoming RAN technologies like LTE or LTE Plus is something that needs to be there. The automated procedures that we bring in our solutions that will simplify the deployment is also a very important issue, because the deployment is going to happen in an environment which is a non-telecom environment. So we have to have all these automated procedures that will simplify the deployment and the installation. And of course, we must have a unit that is not telecom, a unit that will blend in the urban environment, and it will be almost invisible. Because at the end of the day, all the operators, they must have some authorization from a city council, from some other authority, to go and install some telecom live equipment on a lamppost or on a wall in an urban environment.
Mm-hmm. Mm-hmm. Can you also comment on redundancy? What are your thoughts on that specific feature? How does it apply to the small cell environment?
Well, redundancy in terms of carrier grade, in terms of hardware?
Sure, if that's, yeah, I mean, you're right, that can mean different things, but let's address it from that point of view.
Well, in our proposition and having a multi-point element within our solution, very easily we can make redundant the most critical point of these technologies, which is the hub. So we can have hubs that provide coverage, and these are deployed in a redundant way. So whenever one aggregation point fails, we will have a standby that will take over the traffic. So the redundancy is critical on the aggregation, and this is where we are offering.
Mm-hmm. So if I were to go back and ask you about the business case for small cell backhaul, and specifically on the costs to the operator, what do you see are the major costs that the operator would encounter in a small cell deployment, and how does your solution, address the issue of, maintaining low cost or low total cost of ownership?
The fact of the multi-point technology, which for sure brings less equipment, having one aggregation point that has many terminals, that translates into less expenditure. In terms of operational expenditure, in terms of licensing fees, again, the area license spectrum is also very attractive. It's also important that the expenditure is fixed, so the operator knows exactly how much it has to pay for the license. It's not something that will grow in time with more links. Irrespective of the number of links that you will deploy, the operator knows exactly how much the spectrum license will cost. This is very important. And as I said, it may be the case that they have already acquired the spectrum and it's already underutilized, which means that it will effectively bring no more cost. The automated procedures that we have introduced will simplify the installation, which means less time to install. The automation, as I said, means less time. This is also very important for the operator.
Mm-hmm. So I have now
making it small and compact. That will simplify also the site acquisition and probably the costs that are associated with that.
Mm-hmm. So, I'm curious about how you see the overall market for small cell backhaul, and specifically, how do you compare your solution to other backhaul solutions, let's say, that operate in the sub-6 gigahertz non-line of sight or in the 60 gigahertz? How do you see your solution fit within the overall space in backhaul?
First of all, the small cell market is a very new market. Everybody is discussing it. We have very high expectations yet to be realized. So probably by next year we will see the market growing. The major competitor for us is the sub-6 non-line of sight, where I believe that there are many issues there. I mean, probably the bandwidth is not enough. If the spectrum is there and it is licensed, it could be expensive. If it is unlicensed, then it's not a carrier-grade solution. If the spectrum is not there, means that there's not enough capacity to address the needs of small cell backhauling. And at the end of the day, this non-line of sight gives you a statistical dimensioning of the network. This is a varying performance, and by no means this is a carrier-grade solution. And in the long run, I believe that sub-6 frequencies, they are going to be used for the access network. I mean, to address the increasing need for even more bandwidth. On the other end, we have the millimeter technology. It's a very new technology, yet to be proven. We are talking, I mean, our proposition is based on a proven technology. 6 millimeter technology is very new. There are a lot of issues to be solved. For example, we are talking about very narrow beam, pencil beam, and that could create some problems in the deployment of the networks. For example, the pulse wave could be a problem there. And it is a technology that has to be proven, whereas our proposition is based on a microwave, very known technology, proven technology. The engineers know how to use microwave, how to plan microwave, how to design microwave networks. What we are proposing here is how all this all this knowledge is transferred at a street level.
Mm-hmm. All right. One last question. I would like to ask you about how you see your product would evolve in the future. If you can comment on the roadmap, what features you plan to add, and take us through that, please.
First of all, we would like to, we will want the product to address the area licensed bands that we see coming. So 26, 28, 32, and 42 are the frequency bands that we will have our product, and the evolution of our product for sure will have to address all these area licensed bands. Then networking, carrier-grade networking, and putting all the features there that will have the quality of service, the MEF certification, the OAM certification, the MPLS. So all these are issues that are going to be addressed in our solution. And later on, I mean, ultimately, I would say that we would like to see how our proposition can be integrated with a small cell, and effectively having a single unit that can be the small cell and the aggregation in one box.
All right, that's very interesting. Okay, well, thank you very much, Babis, for this conversation. This conversation is part of the Selfalignment report on small cell backhaul that provides an overview of the small cell backhaul solutions along with an in-depth conversations like this from leading vendors who participated in the report. I'd like to thank the audience for listening in. And just to mention that this report can be downloaded from the Sensa-Feely website at www.sensa-feely.com. Thanks again, Babis, for being with us here and for this conversation about your product, the Street Node, and the point-to-multipoint Babis platform. Thank you.
It was really a pleasure for us.